Hello, I'm just going to fire straight away and just go through or talk through marks here and how to answer this question. So essentially this talks about mechanism of reaction 1. So it's attacked by an electrophile. We are to give the reagents used to produce the electrophile first of all. We also have to write the equation to get this electrophile, and then we outline the mechanism. So this is going into our nitration of benzene. So this is our aromatic topic. So if you've got really good knowledge on the nitration of benzene, this is a really tasty question. So before I go into it, we know that benzene is an incredibly stable structure because of its delocalized ring. It takes an electrophile, but not only an electrophile, a very, very powerful electrophile to compromise this delocalized structure. How we do that is we react concentrated sulfuric acid and concentrated nitric acid together, okay? So essentially what we have to do is we have to do a step, first of all, to obtain the electrophile, okay? This step is actually made up of two parts. The first one is that we're just going to react these two together. So what happens is, so first of all, I've already got my mark there, one mark for this, one mark for this. Beautiful, I've given the reagents. So I have to write out the equation now to see if I can form this electrophile. And this electrophile that we form will be involved in the mechanism here. So I essentially have my H2SO4 plus HNO3. And what I get then is I get HSO4 minus plus H2NO3. Now looking at this, if you know your Bronsted-Lowry theory from acids and bases, even though nitric acid has acid in the name, I can see very clearly here that this has accepted a proton, making it a base, and that the sulfuric acid has donated a proton, making it the acid. So that's just a little side point there. Now, what we're trying to focus on is this bad boy over here, because the second step, or the second part to this first step, I should say, is how we then obtain our electrophile of NO2 plus. We will actually be coming back to HSO4 minus. It'll come back at the very end, but I will explain that when we get there. So what happens is, okay, so we've got this, plus, very important. We've got this H2NO3 plus sort of ion here. And what happens is this actually decomposes to form NO2 plus, and of course our water. We have now officially made, not a bog standard, but a very, very, very powerful electrophile. It is this electrophile that is then involved in the mechanism. So bam, I've got my mark. Beautiful. Okay, making sure the charges are correct. This doesn't need to be balanced, it's all good. So now it comes down to being unambiguous with my mechanisms and my curly arrows and my horseshoe, if I remember that. So I've got my NO2 plus, happy days. So I'm going to draw out my benzene ring here. Now, because this is a very powerful electrophile, these electrons here in the delocalized ring are going to really move towards it. Okay, so what happens here is then curly arrow from the ring, curly to the NO2 plus. What happens then is I get this intermediate of H popped over here and my NO2. Now, very important, I have to show this ring is compromised, okay? So I'm going to draw it like this, which looks a bit weird. I'm sorry, you probably can do it neater than me. Now, what's really important to note, you can see that it's this carbon that's sort of being involved in this sort of attack. When you draw the compromised sort of horseshoe delocalized ring, it's very important that you do not go past these two carbons that are adjacent to the one sort of being attacked. Do not go, if you go past those, you won't get the mark like that. Don't go past them. So play it safe. Don't go past the two carbons adjacent to them being attacked. And of course, we have our plus charge there. So this is our intermediate. So what happens is the electrons involved in this carbon hydrogen bond here will actually go back and reform the delocalized ring structure. So essentially I get my benzene, all good. Benzene with my nitro group on it, that's my nitrobenzene. Now obviously I also have this H plus hanging about, like you get full marks here, but just I might as well add further so that you understand what's going on. So this H plus is from this H that's been eliminated. Now if you remember back from the equation here when I make my HSO4, this actually attacks the H plus. This is just a little side note. okay? And this reforms my H2SO4. So essentially, because this is being reformed, it's not being used up in the reaction, this is my catalyst as well. Okay, so I've got 1, 2, 3, and 4, 5, and 6 marks. Okay, any questions, do let me know.